So right there, we just dropped this from the tab here, param, primitive, integer. Drop that down. So to delete a component, let's say I want to delete this one, I can select it by either dragging over it or just clicking on it here with my left mouse button. So if you're using a non-Macintosh computer, you can just hit delete. If you are using a Macintosh computer, I think it's function delete or control delete or command delete. If someone gets it, shout it out. And function delete. So it's function delete on Mac. Okay, if worse comes to worse, it worked? No? If for some reason you can't get it to work, another thing you can do here is go edit, delete. So Rhino actually does have a command line as well. So if you want to access the command line, it works more like a search tool rather than knowing the exact command. So it's super helpful if you double click on a blank part of the canvas, so not on a component, but double click there, it's going to say enter a search keyword. So if you're reviewing a file and you see it says int, but you don't know what int is, you can just type int and you're going to see it's going to pop up integer. So like that. So it's nice. It gives you a bunch of suggestions. So I'm going to select integer, so you can just click that, and now we have another integer like that. So another thing you can do, so we're going to actually add 1 plus 2 plus 3, is you can, if you want to copy a component, you can either hold, you can start dragging it, so click it, start dragging it, and then hold Alt, and you're going to see this little icon pop up, so you can see it's this ghosted box. Let go, and it's going to copy that component. Or, and this is the way that I do this, so in class, if you see me quickly copy something like this, you can hit Control-C, Control-V, and then another one will pop up. And that's how I do that, because a lot of times if you need a bunch of these, you can do it really fast. And it'll pop up like that. So we have 3 components. So what I'm going to do now is this, I'm going to grab a special component here, and this is going to be one of your best friends in Grasshopper. So if you go to parameters, input, panel, you're going to see this yellow square here. Okay, and I'm just going to move these down. I'm going to copy this panel 3 times. So in the same way, I'm just going to go Control-C, Control-V, Control-C, Control-V. So now what we're going to do is we're going to connect these. So to connect 2 components in Grasshopper, to link them up, what you're going to do is you're going to grab the right side of the component you want to link into another component, and you're going to see, hold down your left mouse button, and you are going to drag it to the other little left node of your component like this, and you're going to see it's going to snap into place. So it's kind of snapped, and then you let go. So that's connected. Now, I'm going to do that for all 3 of these. I'm going to connect them. So you can see if I connect all 3 of these, essentially what's going to happen. is it's going to say no data is collected. And that's because panels essentially just tell you what's in a component. They're just a nice way to look inside a component. They can be used for other things as well, but at this point, this is what we're going to do. So another thing to know about connecting while we're on the topic is you can connect more than one thing to a component. So in this case, if you hold shift, so let's see what happens if we take this component here and try to connect it to this panel. What's going to happen is it's going to disconnect this first component, and it's going to connect this component here. If we want to connect two things to one component, you have to hold shift. You see this little green arrow here, a little plus icon, and you can drag it in now, snap it, and now you can connect more than one thing to the panel. If you want to disconnect a panel, you can hold control, just like deselecting something in Rhino, and drag it to the component you want to disconnect, and there you can see it disconnects. So right now, since we're not really doing anything, just as far as it comes to like connecting, disconnect, just think of this as like an exercise in making, like hooking up things with wires, which is essentially what Grasshopper is. So this is just like getting to know how to use it. Does anyone have any questions with? No? Okay, so you can see here that no data was collected. So we're going to look at the ways in which we can add data. So the first way you can input a value into a given input. On any component, you can right-click it. So right-click on your first int component, so integer component here. And you can see this pops up. There's a few things we can put right here. In this case, we're just going to go to set integer, and we're going to put in 1 and commit changes. So you can see now that this integer, it's outputting 1, and you can see in this parameter, or this panel here, it says 1. So it's telling us exactly what's in this component here. It's 1. If you don't want to use a panel and you just want to find that out, you can just hover over a component and it's going to tell you what's in it. So you can see in that lower box right there, it says 1 locally defined value, 1. Another nice thing that the integer, or the hovering over any component will do is it'll tell you exactly what that component does. So in this case, integer, int, contains a collection of integer numbers. So that's all it does. It just contains numbers. Another way to input data is to connect another component to it. So right now, this is an empty container. If we connect this integer to here, you're going to see that it's going to get this value from this integer. So it's sort of moving that data forward. Now you can reuse data, so like this 1 never goes away. So that's a way you can do that. Another way we'll look at something, another useful component that we can use to input data is in parameters, input number slider. So that's parameters, input number slider. And what you can do is you can take this, put it into integer, and as you move this around, it's going to change the value. Now, in this case, you'll notice that this slider here, I'm moving around this slider. It's going from 0 to 1. It's a floating point number. Does anyone have an idea why on this panel here it's 1? Does anyone want to hazard a guess? Exactly, it's rounding it. And the reason why it's rounding it is you look at the integer component here. It says integer contains a collection of integer numbers. Integer numbers being whole numbers. So it's only going to output integers. So if you put in a float, a decimal point number in here, it's going to output an integer. So if we want to change that, all we'd do is we'd take this slider here, plug it directly into the canvas. Now you can see as we move this around, it's going to change that value there. Another way to disconnect, so we have this integer here, we want to disconnect it, so we've already done holding control, moving out like that. Another way you can disconnect a component is go to right click the input here and go to disconnect, and disconnect, it'll highlight the one that you're disconnecting, so you can see that disconnects. So now you can see we have three numbers. We have 1, 1, and 1, but something that can slide between 0 and 1. So another thing to mention here is you'll notice that these components are gray and this component here is orange. So what does that mean? Essentially, if a component's gray, it means everything's fine. Things are working, you want to see gray. If a component's orange and has this little bubble here, if you click the bubble, it's going to tell you what's wrong. So orange, it's a warning. So floating parameter int failed to collect data. So in this case, what that means is we haven't put in anything. A lot of the times orange is not bad, it's just a warning. It's sort of halfway between good and bad. You know something has gone really wrong when, in this case, let's go to integer. I'm going to go set one integer, and I'm going to put like coffee. Oh, it won't even let me do that. So here, I'm going to type in coffee here. Coffee. Going to plug that in. It's going to turn red. So you can click the little error message. So data conversion failed from text to integer. So that means something's just totally going wrong. If you see red, I'm going to say like 98% of the time, it's not going to be doing what you want it to do. Okay. So I'll just delete that. So now we have these three values. We want to do something to it. So these are our inputs here. Let's go to math, operators, addition. So you can see here A plus B. If we highlight over this component, it's going to tell us what it's going to do. Mathematical addition. Very exciting. Why don't we try plugging in 1 plus 1? So A plus B. Let's grab another panel. So parameters, input, panel. Put out the result here. And it's 2. So amazing, right? All of you guys right now want to become parametric designers for life, right? So to sort of add a twist to this story, what you can do on some components, if you zoom in enough to certain components like this one, you're going to see there's these little pluses and minuses that come up. And if you do see this, what this means is if you click on a plus here, it's going to add a different input. So minus gets rid of that. So now in this case, what this means, of course, is you just are going to add in a different input. So let's take this, plug in there. You can see our output is 3. But as we slide this around, you can see that the output of the final component is changing with the slider, and the output of the slider itself is changing. So this is the thing about Grasshopper, is it's always going to update everything that's connected downstream from it. So as you change the inputs, the outputs are going to change in step. As you're going through this course and working on your own projects, you'll notice that the outputs do not always change this real time fast. In fact, you're going to find that your computer freezes a lot during this course. But I'm here to hopefully help you avoid that. So does anyone have questions about adding 1 + 1 + 1? Okay. So does anyone have questions about the general Grasshopper interface or anything? Okay. So this is one other thing I'll say here. So we've sort of gone over that. Let's look at a few more things in here. If you ever get lost, like we're way out here in the middle of nowhere, you can go to View, Zoom, Zoom Extents, and it'll bring you back. Another thing is this little compass here, which you can move around if you want. It's going to show you, see how it moves up and down? It's essentially going to be guiding you towards your components, so you can see it very nicely. Goes like that. Another thing we can do, so kind of interface wise, if you want to group some things, and I'd suggest that you do group steps in Grasshopper, just as a nice way of organizing them. You select the objects you want to group, like this, and then go group, like that. And now you can see those are a group. One other thing I'll say, and we'll sort of pick up on this, is if your computer ever is freezing while playing around with Grasshopper and you're moving a slider, one thing to remember that you can always do is right click on an empty part of the canvas, click Lock Solver. You're going to see this little padlock icon come up. Now look at this result here. If I move this, you're going to see it says no data was collected, because it's not computing. It's you can change the inputs. It's not going to do anything. But now when I right click and click Lock Solver again, it turns it back on. Now it's going to update. So that's right click, Lock Solver, make your changes, right click, Lock Solver. So that's going to actually prevent a lot of lagging in your computer if you're working with a lot of things.
How do you have this lock tab? I don't have it.
Oh, I right clicked Lock Solver. Yeah. So there's a lot of things, Grasshopper support, solution, display. We won't really get into this too much. Like there's kind of, I don't even know what that is. But kind of look that up in the Grasshopper primer. The one last thing that I will say right away is when you're working in Rhino, Grasshopper has its own file extension, so its own file type, as well as you need to save your own Grasshopper file. So usually what's going to happen is you're going to save the Rhino file in the corresponding Grasshopper file. So you're going to go to File, Save Document, and you're going to see it's not a Rhino file, it's a Grasshopper binary file, so .gh. You always want to make sure to save your Grasshopper file. So in this case, I'll save is March 7th. So this will be the class file that I'll save. And then you'll also have a Rhino file. So you're probably going to want to save and save as a lot too, because again, Grasshopper is prone to crash while you're learning it, so it's good to save often. So I guess we're just going to go through a few examples of how you would use Grasshopper to actually create small steps to actually make, you know, actual geometry. So if you don't want to use these components, and I'd suggest you do this quite a bit with components that you aren't using, and that doesn't mean components that lead into components that you're using. It means things like entire sections that you're not using. You can select all of these, right click, and go to disable. And you can see now they turn kind of like darker, kind of muted gray like that. That means that they're not working anymore, and that's good for us because this means that they're not taking up any computing power, so things can run faster. So what we're going to do is we're going to make a parametric tower. So we're going to do this with Rhino and Grasshopper. And I talked about how parametric design does not always need to be in Grasshopper, so we'll actually be doing something parametric in Rhino. So what I mean by that is I'd like you all to draw some rectangles like this. And you can either copy these rectangles up. I'm going to do 3 rectangles. So one, I have gumball on. So to turn gumball on, of course, sorry, my screen's like really condensed here with this projector. You click gumball here. So turn gumball on, hold Alt, drag up that rectangle. You'll see that little plus icon. So I'm just going to have 3 rectangles like this. And this is going to be essentially the beginnings of my tower. So kind of like that. Now, I'm going to show you something called record history, which I think is very useful for iterating through lots of design options. So you're all familiar with the command loft. What I'm going to do, and follow along, is hit record history once you have your rectangles. So hit record history, make sure it's bold, highlighted there. And then go to surface, loft, or else type in loft in your command bar, whatever you prefer. Select curves to loft. Select them in the proper order, from the lowest to the highest, or vice versa. Hit enter. Make sure your curves are aligned, so arrows all facing the same direction. So hit enter, and I'm going to go for a loose loft in this case. I'd suggest you do the same just for most flexibility. Go to do not simplify, and we don't want it to be a closed loft. Hit OK. Now I'm going to go to shaded. So you'll notice the record history is no longer highlighted, and you're probably thinking like, oh, well, that's, you know, not cool, not fun. Essentially what record history will do is it records the history of that command. So it knows that these 3 rectangles here are linked. So now if I drag out this, it's going to change. Drag out that, it's going to change. If I even twist, it's going to start to twist things. So the reason why I like working with record history sometime is it's more of an intuitive way to kind of design, especially if you're making twisting towers. So in this case, what we have here is we have now what you call a parametric model of this tower. So it's parametric. Why? Because our parameters are the position and orientation of these rectangles. The algorithm is loft, and no matter what we do to those input parameters, the loft is still going to happen. So does anyone have any questions about that? That's sort of the extent of the Rhino side we're going to work with. But the reason why I like doing this in this class is just to show that parametric design need not be in Grasshopper.
I didn't seem to find record history when I hit my command bar. In Rhino, there was no...
Record history should be down here by the snaps and gumball. Did that work for you?
Well, I'm using the macros. I'm not quite sure where it is located. I think it's like actually a top. I think not.
Okay. If for some reason you can't get record history to work and you really want to follow along regardless, just, loft some curves. It's no big deal. The other thing too is in this class, like for this, easy enough to follow along. You'll find in the future when I have to like get through a decent amount of stuff, it's hard to follow along. So again, tell me to stop if you want, but also know that I am recording everything for your review, so don't feel super stressed out about stuff. Okay, so one thing to know about Grasshopper and Rhino is they don't really, you need to make them talk to each other. Grasshopper objects are not Rhino objects and vice versa. So what do I mean by that? If we wanted to perform Grasshopper commands on this object here, anyone have any idea how we do that? Yeah, exactly. It's just like input. So what it's called is referencing. So again, in our parameters tab, so parameters are the inputs. If you go to geometry, we look at what kind of geometry this is. So for any time you have an extrusion, a poly surface, a B-rep, so a closed poly surface, you're going to choose B-rep. So remember B-rep. So B-rep, what it stands for is boundary representation. So that's essentially, it's a bunch of points and curves that come together to make a shape that we can understand. It's made up of more than one surface, so if you have something like that, again, that's going to be a poly surface. Choose B-rep. So I'm going to go geometry, B-rep. I'm going to put that down on the canvas. Now, the way you reference geometry in Grasshopper is, now you can select this before or after, but you're going to right-click this B-rep component, and you're going to go to, in this case, we just have one B-rep, so we're going to go to set one B-rep. Now you'll see the Grasshopper will minimize, and it says B-rep to reference. We can click our object there, and so this little timer came up. We can hide that. Not sure why that came up, but that's okay. If that does come up, you can click Hide Profiler. Oh, actually, I know why. It's because I turned on Profiler. Okay, that makes sense. Sorry. So let's try that again. So if I select this B-rep here and go to right-click, set one B-rep, you can see that it doesn't minimize, it just automatically selects that. Now, let's go back to, so in the Rhino window, you can see something weird's happening here. There's kind of like the Rhino gray overlapping with the Grasshopper red. Let's go to view wireframe to sort of see what Grasshopper looks like. So this Grasshopper object here, it's referencing, it's not the Rhino object. So like, let's say we hide the Rhino object. So I'm selecting the Rhino object. I'm going to hit Control H to hide it. I can't select the Grasshopper object here. You can see I can click in my Rhino screen as much as possible. It's not going to happen. And that's because the Grasshopper object's just referencing it. It's not copying it. It's not making an object in Rhino. But however, it's still linked to that object in Rhino. So if we do something like, in this case of record history, let's say we move all of these curves, it's going to move with it. If we make this twist, the Grasshopper object's going to update with that twist. So it's not that object, but it references that object no matter what changes happen to that object. Now, in Grasshopper, if you want to see what a component refers to, if you click it, you can see that the object that it refers to turns green. So that's the current object you're selecting. You click away, it turns red. So red means not selected, green means selected. Okay, so now, so essentially what we're going to do here is we're just going to more or less array a surface or one object on this object. So what I want you to do is I'm going to turn back on shaded. So view shaded is in Rhino again. We're actually just going to reference another object. So I'm just going to think of a pattern that we're going to put all over this guy here. So I'm going to go to rectangle, corner to corner in Rhino. So I'm just making a little square. So in this square, I'd like you guys to just, I don't know, draw some lines. Just make sure it's sort of within the bounds of the square, and this is going to be the pattern that we're going to be putting all over our twisty surface that we made. So that's what we're doing using Grasshopper to do, is to sort of put this pattern all over our original surface. So I'm making that beautiful pattern there. Actually, that pattern's not beautiful at all. So I'm gonna make a pattern that actually lines up. Remember that for any pattern, if it doesn't meet up at the curves, then you're gonna get a disjoint thing. Don't worry about that though. So I'm just quickly making kind of like, I guess, a Union Jack style lattice pattern. And your pattern can be a happy face, a sad face if you really don't like this. It can be whatever you want. Sometimes in these classes I really do start to like relate to Bob Ross, and just when I catch myself describing things. Okay. So I'm just making this pattern here. However you want to make a pattern, it is all good. Okay. So I have this, and then what I'm going to do is I'm just going to extrude this to make a poly surface like that. So your pattern can be curved, whatever, as long as it more or less falls within that shape. So here's mine. So I'll just give you a second to catch up. Does anyone have any questions about that, or no? Okay. So we're going to reference this as well. So again, this is an object that has more than one surface in it. In this case, it's an extrusion. What we're going to do is we're going to go to Geometry BREP, because BREP for anything that has more than one surface. We're going to click this. We're going to right-click BREP and go to Set One BREP, and now you can see it's referenced. If we go to shaded, or sorry, wireframe, you can see here's this object, here's this object. So we have our two objects referenced here. Another thing you can do with components, and this is a good habit to get into because it keeps you organized. If you go back to a Grasshopper file later, you're not going to get confused. Is you can label these components by right-clicking them and labeling them at the top there. So if right-click, you can see this here. It's the actual title for this component. So I'm going to change this to tower. And in this case, I'm going to change this to pattern. Oops. And so tower and pattern, like that. So now we know we don't even have to click it to find out what it is. So if we're thinking about, again, like I said, pen and paper is your best friend. for working in Grasshopper. So what I want to do, what I dream of doing is taking this pattern here and essentially repeating it across all these faces in a way that follows the curvatures of the surfaces. So you guys can kind of visualize that, like this lattice pattern repeating over all of these surfaces. So before we even go into components, we have to think of like what are the steps we can do to make that happen. Maybe since there's a chalkboard, I put the eraser underneath the projector. Okay, so, okay. Okay, so we have that. So let's just look at one surface like this. So this is one side of our poly surface there. So if we're going to tell the computer how to do this, and we have our object here, let's say that's our object here. Okay, so if we want to repeat this surface, what do you guys think the first step to tell the computer is? What would you do if you're explaining this to the computer?
To scale?
Close, but what do you scale to?
To the base size?
Well, we don't want to do it on the base. We just want to put this shape repeated on all these surfaces. So let's think about repeating. To repeat something on this surface, we should divide this surface. So the first step, if you were going to tell a computer to do this, so computers are stupid. You're going to say, computer, repeat this pattern on this surface. And it's going to say, okay, I know what surface you're talking about because we referenced it, but it's going to say, what's repeat? And also it's going to say, how do you want me to repeat it? So we say, we want you to repeat it in a grid. Like that. So that's our step. And then the computer says, okay, cool. I have this grid on the surface. I have this here. What's the next step? How would you tell the computer to repeat this on all of these? Yeah, exactly. That's perfect. So the next step is, okay, we have one of these. We essentially, to repeat it, have to move it, right? To each of these. And then, if we do that for the surface, it works. So in this case, it's as simple as that. And that's sort of what I mean when thinking about the steps in the pen and paper. I guess in the same way that like gymnasts chalk their hands. I'm ready for Grasshopper. So those are the steps, even before we think of the commands. So in this case, there's really just two steps to that algorithm. You need to think about how you're going to do that, especially if you're coming and like talking to me for help. A lot of the times it can be like, I just can't help you if you don't know what you want to do. Like if you come to me and you're like, I want to make this look cool, I won't know how to do that. Not saying that I don't know how to look cool, but if you come to me and you say, okay, I want to take this surface and morph it and put it, 10 times on this surface, like exactly step by step by step what you think you need to do, then I'll be able to help you, no problem. So that's a big thing in this. I just want you to kind of think through all the steps. And then after that just becomes building up experience to learn which components do that. So to divide a surface like this, we're going to use a component called math. So it's in math. And we're going to go to divide domain. So you can see here it says divide a two-dimensional domain into equal segments. Oh, and you can see there already it's like, no, that's wrong. So I forgot a step. I kind of implicitly put a step in there. So in this, we're just referring to each side, right? We're not referring to the whole thing. So the first thing we need to do is break up this tower into its 4 sides. Okay, so first step, breaking up the tower into 4 sides. We go to surface, analysis, and then we can go to deconstruct BREP. So surface, analysis, deconstruct BREP. We plug our tower into the deconstruct BREP component. So again, if you highlight over it or hover over it, it's going to tell you what it's going to do. Deconstruct a BREP into its constituent parts. If you hover over B, it's going to tell you what it needs. So every component's nice in that way. It tells you what it needs and what it puts out. So in this case, it says base BREP. Here's our BREP. And now if we look at its outputs, it's going to give us faces. So that's what we want. And you can see here there's 4 values there. If we look at a panel, so I'm going to go to parameters, input panel, just to see what's going on in here. You can see it's telling us untrimmed surface, untrimmed surface, untrimmed surface, untrimmed surface. It's pointing out some other thing. So hover over the E there, edges of BREP. So it's giving us all these edges. And then the last thing, vertices of BREPs. Those are these points here, which it's giving us. So the points that sort of define the corners of this shape. But we just want the faces. Now, one thing to note here is you can see how this has gone a bit darker because there's 2 shapes overlapping each other. Because they're more or less the same thing. It's just this is broken up. In Grasshopper, this geometry is always there. In every step of the way, this geometry isn't deleted once you put it into something else. It's still there. If you start getting too many things on your canvas, what you can do is you can click on a component, you can right-click it, and go to Preview, and turn it off. So right-click, Preview, you see on, it gets darker because it pops up. Right-click, Preview, it turns it off, like that. So now if we click this, it's not going to turn green because it's hidden. So we have our surfaces. I'm just going to delete that. Now what we want to do is go to Math, Domain, so Math, Domain, and then divide domain. So base domain, we can put in these faces. You can see it's not angry anymore. U and V. So I'll explain this on the board. So divide domain. So divides a 2-dimensional domain into equal segments. You can see it has a little square there going to a grid of squares. U is 10. V is 10. So if you guys were in Rhino 1, you'll remember that actually, it's easier to explain this in Rhino. My hands don't get dirty.
Sorry, my divide domain is different.
Yeah.
And an I and a C.
I see.
2 inputs. Divide domain squared.
Yeah, so divide domain squared at the bottom there. Is that the right one? Okay, perfect. So what we're doing here is, so I'm just going to preview off all of this so you can see we have this. So in Rhino, you can see that we have our world coordinate system here, so Cartesian plane. So we have our x-axis. You can see right there, x, positive values, negative values. Our y-axis, so you can see y here, Y is this direction, and Z is up and down. So that makes sense to everyone. But there's also another coordinate system called UV. And what a UV coordinate system is it's a coordinate system in Rhino specific to a geometry. So don't worry about, recreating what I'm making here. So if we have a surface here, I'm just going to turn on display isocurves. So if we have a surface here, you can see that this surface is in the world coordinates. This point on the surface here, it's about 0, 0 in world coordinates, or 0, 0, 0, sorry. But you can see here that this surface itself actually has its own grid system on it. So in this case, the surface here is 0 to 1 in what's called the U direction, and 0 to 1 in the V direction. So even though this is 0, 0, 0 in the X, Y, Z coordinates, related to this surface, it's actually U equals 1, V equals 1. Now, this isn't just for flat surfaces. If, let's say, we were to kind of make this a twisted surface, this is still U equals 1, V equals 1. It's just the grid skewed. So that's the difference between a UV grid on a surface and the overall XYZ grid. So the reason why I say that is now if we look at that component, so divide domain, the input, even though it doesn't say surface, it says base domain. If you can look at what it's being input, it's U 0 to 1, V negative 58 to 0. So essentially that's the U and V domains of that surface. And it's dividing it up into segments. So it's dividing, in the case of, this surface here, it's dividing the U direction into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 segments. So if we want to do this in Rhino, we could go to, surface tools, rebuild, U equals 10, V equals 10. And you can see now we're dividing that surface up into segments, that UV domain into little sections like that. So that's what we're doing here. Does that make sense to you guys? Ish. It's the kind of thing that's actually by this class's standards. I think that's a pretty good response. There's a lot of times where things are just kind of like, oh, that's weird, but you get used to it. If something just totally doesn't make sense, please advocate for your right to learn and to knowledge. Tell me if I'm just not making sense. Okay, so what I did there is I just right-clicked my deconstruct brep and I turned on preview. Okay, so we've divided our surfaces into UVs. Now, if we look at that little diagram there, right now we have our domains. So you can see if I take a parameters input panel, take out these segments looking at it, you can see it's a bunch of numbers. So these are essentially the commands. But we haven't yet made those little boxes. So essentially we just need to make those boxes. What we're going to do now is we're going to go to transform, morph, and we're going to go to surface box. So that's transform, morph, surface box. So let's hover over. It says create a twisted box on a surface patch. We look at the output of the domain divide there, individual segments. So that's our surface patch. So it's going to ask for our base surface. we have our faces here. We're going to put our faces into the base surface. It's going to ask here for our surface domain. We have our domains right here. We're going to put it in there. And it's going to ask for one more thing, our height. I'm going to explain this next class. So sometimes in Grasshopper, you're going to see, you're going to be like, something worked, but it didn't work how I wanted it to. And that's essentially, I was talking about data management. So keeping track of the way your data is organized, that's going to be another topic another day. For right now, what I want you to do to make this work here is to right-click this S and click on this thing there called Graphed. And now it works. So if I were you, like, totally bask in me saying, like, don't worry about what graph does, because this will, grafting and data management will be like the #1 thing I'll be on your case about in this class. So it's just super useful. Now the other thing we have here is the height of the surface box. So you can see right here it's 1 by default. We hover over its default. Why don't we put a slider in here just to be able to control the height? So sliders, again, they're in parameters, input, number slider. So I'm going to connect the output of this slider into the height. And now you can see what happens is we move this slider, it moves in and out. Now, this doesn't move in and out that much. 0 doesn't even make sense. So let's say you want to edit a slider. To edit a slider, you just double click on its handle here. So where in this case it says height, it might say something else depending on what you hook it up to. And now you can see this little slider properties dialog box comes up. You can see that you can change its name, you can put in an expression, we'll worry about that later. Grip style, shape and text, I just leave it at that. So slider accuracy, you can set it to floating point numbers, integers, evens, or odds. But here's what we kind of want to worry about right now. So you can set the minimum. I'm going to set the minimum by double clicking this to be 1 and the max to be 20. So 1 to 20, hit OK. And now you can see with these boxes, now they can grow bigger and smaller. See, now another thing to mention about this and just to keep in mind is all of these things, again, are in order. So in this case, if we twist this back, you can see everything updates. If we twist this again, everything updates. Move it up, everything updates. So this is a way to kind of iterate through different design options. Okay, so the last thing we're going to do, because we only have 5 more minutes left, is we're going to go to our pattern here. So I'm going to go to preview on our pattern. So now our next step, sort of like we said here, that arrow, we just want to move this pattern into these boxes. Now the way we do this is essentially we're going to take this pattern, we're going to put it in a box, and we're going to say to Grasshopper, this pattern in the box, translate that pattern's location in that box to another box. Since we have a lot of boxes, we already got all the ingredients. So that it's called box morphing. So the first thing we want to do is to make a box around this pattern here. To make a box, it's called a bounding box. So again, this is in Rhino as well. So we're going to go to Surface, Primitive, Bounding Box. So you can see, drop that in there. So you can see it says, solve oriented geometry bounding boxes. In short, it means it's going to put a perfectly sized box around something. So let's look at the inputs. Geometry to contain. The second input is bounding box orientation plane, world XY by default. We don't really have to worry about that, so we're just going to plug in our pattern into C, and you can see now we get a box around our pattern object that fits it perfectly. All right. So I'm going to preview off this, and I'll leave that on. Actually, so yeah, just get used to previewing things on and off. So in this case, like, I don't really need this anymore, so I'm going to preview it off, and you can see it starts to make things a little bit easier to see. I always just like having, you know, the one or two things I need at that step. Okay, so we have our boxes here. We have our bounding box here. The component which will make the magic happen and change these, or translate this to here, is under transform, morph, and then we're going to go to box morph. So that's transform, morph, box morph. Highlight or hover over it, morph an object into a twisted box. So we have an object, we have some twisted boxes, so that sounds good to us. Highlight over the first input, G, it's base geometry. So that's referring to our pattern, so I'm going to plug in our pattern. R, reference box, that's our bounding box here. So I'm going to plug that into the reference box. And T, target box, so that's the box we want to put in. And you'll notice it's going to take a second. So this is, like I said, when Grasshopper, it won't freeze, I hope. Now why would it? Yeah, so it did that. So if it is taking a while like that, just relax, enjoy. Now I'm actually not sure why it, oh, I think it's because it auto-saved. Who knows? But so the reason why, let's look at our pattern. The reason why that took quite a while, now I have this crazy built up thing, is if you think about the way we divided U and V, it's 10 by 10. So that means we have 100 of these objects on each surface. So that means we have 400 Rhino surfaces. So, okay, so I'm going to hide my Rhino curves like this. And we'll cover the one last thing in class. So we have this crazy tower type thing here. It's intersecting in weird ways. So here's a good case where you would use lock solver. So if I'm like, this is way too thick, I'd go to lock solver. Then I'd change this to 1. And then I'd go to lock solver. And see it's updating. But this way, if you use a slider and you haven't locked the solver for something big like this, what it's going to do is it's going to solve, let's say you're sliding between 10 and 1. As you slide through, it's going to solve for like 9, 8, 7, 6. So it's going to take a long time. Sometimes if Grasshopper is solving, your Grasshopper window is also going to disappear. And that's okay. So maybe change your U and V to be lower, but there we go. So that's great. So cool tower there, but this isn't a Rhino object, so we can't select it. The last thing I'll show you is if you want to take all your Grasshopper work and bring it back into Rhino so you can render it, you can add in more modeling like stairs or, you know, whatever, place in a site, select only the final, like the final geometry. So in this case, it's the box morph. If you select it, it turns green, so you know that's what we're referring to. Right click it and hit this little fried egg called bake. And you're going to get this dialog box that pops up that's going to ask you what layer you want to bake this onto. So decorations, nah, don't really worry about these. Mode. So group, you can group it. So yes, please. Default, user text if you want. Hit OK. So for big objects like this, again, we'll take a second, but there we go.